Hello everyone. In this video, we will be discussing about neural networks. What are neural networks? What are its applications, different layers in neural networks, and its implementation using Python. So let's begin with definition of neural network. So a neural network is a combinational model inspired by the structure and functions of the human brain. It consists of or neurons organized into different layers. These neurons process information and learn from the data through a process called training. Each neuron applies a mathematical function to its input, passing the result to the next layer. The key component of a neural network or the different layers of a neural network are listed below. First, input layer, then hidden layers, then output layers, then weights and biases. First layer is input layer, which receives the input data. Second, hidden layer, it processes the input and passes it on to the next layer. Third, we have is output layer. The output layer produces the final output. The fourth we have is weights and biases, parameters that determines the strength of the connection between neurons. Next, we have different layers in neural networks. So these are different layers in neural network in which one layer generates or processes an information and it to the next layer. For example, in this, the hidden layer 2 processes the information and passes its result to the next layer. Then we have how neural network works. First step is the input. The input data is fed into the input layer. This is the input layer here. And second we have is propagation. In propagation, the input is multiplied by weights and added to a bias, then passed through an activation function. Third step we have is activation. The activation function introduces nonlinearity, allowing the network to learn complex patterns. Fourth step we have is output. In output, the final layer produces the output which is compared to the expected output. Fifth step we have is backpropagation. The error between the predicted and the actual output is used to adjust the weights and biases to backpropagation. Sixth and final step we have is training. In training, the process is repeated multiple times with different training examples to minimize the error. Then there are certain real life examples of neural networks, examples or applications of neural network as well. First we have is it is one of the popular neural network is image classification. For example, given a dataset of handwritten digits, a neural network can be trained to recognize and classify each digit. Today, we'll use the MNIST dataset, a famous dataset of 28 by 28 pixel images of handwritten digits. Second application we have is machine translation. In machine translation, text from one language is converted to another language, such as Google Translate. Then third application we have is sentiment analysis. In this, the sentiment of a text like positive, negative, or neural network or social network, media monitoring, and customer feedback analysis are determined. Then we have text summarization. In this application, a long text is condensed into shorter summaries. Then final application we have is image classification. In image classification, an object is identified and seen with images such as categorizing photos or medical scan. Then here is the code related to neural networks and output that is generated with the help of this code. And here is the explanation of the previous code, in which first we import some libraries such as TensorFlow, which is a powerful open source library for machine learning and artificial intelligence. Then we create a simple sequential model, which includes a dense layer. A dense layer is a fully connected layer in which every neuron is connected to other neurons. Then we have is the activation function. It introduces nonlinearity in the code. Then we have compile the model. In compile the model, there is a loss function which measures the error between predicted and actual outputs. Then we have is optimizer. It adjusts weights and biases to minimize the loss. The next we have is train the model. In train the model, there is a fit in which it helps to train the model on the training data. Then we have is batch size. In batch size, the numbers of sample processed before the updating the model parameters. It specifies that. Then finally we have is evaluate the model or evaluation of the model, in which the model is evaluated on its performance on the testing data. So this was all regarding neural networks. I hope you liked the video. Thank you.